So, hello and welcome in this second video on the topic trigonometry. Okay, so again we discuss some problems related to the topic trigonometry. Okay, so in our last video we discussed about the relationship about between the side ratios of the sides and angle of a triangle. In particular, we discussed 6 trigonometrical ratios. Okay, and we obtain the trigonometrical ratios in terms of the sides of a right angle triangle. Now, we will in today's video we will discuss some problems, okay, some problems on trigonometry. Okay, so some problems on trigonometry, or you can say not. We can consider this as on the trigonometrical ratios. Okay, so trigonometrical ratios. So we will discuss some problems and so that you can have a clear understanding of the concept of these trigonometrical ratios. So, in our first problem, we are given a right angle triangle in the right angle triangle ABC. We have angle ABC as 90 degree. We have the sides AB as 3 centimeter and the side BC as 4 centimeter, and we have to obtain number 1 sine of angle A, and number 2 we have to obtain cos of angle C. Further, we have to check is sine of angle A is same as cos of angle C. So, this is what we have to check. So, let us begin with the solution. So, let us consider this triangle. So, we are given this right angle triangle. So, let us consider this as A. So, it is 90 degree at B. So, let us consider this ABC. So, we are given that AB is 3 centimeter and BC is 4 centimeter, and we have to find sine of angle A. So, as we discussed in our last video, that whenever we have to find the sine of any angle, so we have to consider the two sides. The first is the side opposite to that particular angle. Okay, so for angle A, the opposite side is BC. Okay, and the second thing is the hypotenuse. So here we are provided the length of this side BC, but we are not provided or we are not given the measure of the side AC, but we can use the Pythagoras theorem to obtain the side AC. So, first of all, we obtain or we apply the Pythagoras theorem. So, using Pythagoras theorem, we obtain AC square as AC square, this is not AC square, AC square as we can obtain this as AB square plus BC square. So, that will be 3 square plus 4 square. So, this is coming out as 9 plus 16, which is 25. So, this implies that your AC is 5 centimeter. So, this is coming out as 5. Now, we know that sine of angle A. So, we have to consider the opposite side. So, that will be BC over hypotenuse. So, that is AC. Now, BC is given as 4 and AC we obtain as 5. So, this is the value of sine A. Now, next we obtain the value of cos. So, cos of angle C will be, so when we obtain the cos of any angle, so we have to consider the adjacent side. So, if you consider this angle C, so adjacent side is BC. So, that is BC over hypotenuse, so which is AC, and this is coming out. So, measure of BC is given as 4. So, this is coming out 4 over 5. So, this is the first and second part for this problem. Now, we have to check, or we have to verify that sine of angle A is same as cos of angle C. So, from here we can easily conclude that. So, if you number this as 1 and 2, so from 1 and 2, it is clear that sine of angle A is same as cos of angle C. So, this is true. Okay. So, this is a very simple problem. Now, consider the next problem. So, here in this problem again we are provided with the a right angle triangle. So, we are given that in triangle ABC, right angled, this triangle is right angled at B, and we are further given that if angle A is same as angle C, which is 45 degree, then we have to prove that, we have to prove that number 1, that sine of angle A as same as sine of angle C. Number 2, we have to show that cos of angle A will be same as cos of angle C. Number 3, we have to show that sine of angle A plus cos of angle A is root 2, and 4, we have to show that tan of angle A plus cot of angle A is same as 2. So, again let us begin with the solution, and before we begin with the solution, let us make the diagram for this problem. So, we have given this right angle triangle. So, let us consider this right angle triangle. So, this is this right angle triangle is right angled at B. So, let us consider this, and further we are given that angle A and angle C are both 45 degree. Okay, so these are 45 degree. Now we have to show that sine of angle A is same as sine of angle C. Now here if you look at this problem, so we have to use a concept that the sides, so we have to use a concept that sides opposite to equal angles are equal. Okay. So, as you can see that angle A is 45 degree and the side opposite to this angle A is BC, and angle C is 45 degree and the side opposite to this angle C is AB. So, let us assume that these are both x. Okay. Now, if you obtain, so here you can mark that let AB is equals to BC is equals to x. Why AB and AB and BC are equal? Because they are sides opposite to equal angles or the same angles. So, you are having this AB is equals to BC and we are assuming that this is x. Now, if we find sine of angle A, so again whenever we have to calculate the sine, so we have to consider the opposite side. So, that is BC. So, this is BC over AC. Now, similarly, if you consider sine of angle C, so now the side opposite to angle C is AB. So, this is AB over AC. Now, we are assuming that AB is x and AC we will consider as AC. Similarly, this will be x over AC. So, if you consider this as 1 and this as 2, so from 1 and 2 we conclude that sine of angle A is same as sine of angle C. So, sine A is same as sine C. Now, in the next part we have to show that both cos A is same as cos of angle C. So, in part 2, so when you calculate cos of angle A, so that will be when we have to consider the cos, so we have to consider the adjacent side. So, adjacent side to angle A is AB. So, that is AB upon the hypotenuse. So, that will be AC. So, this will be x over AC. Similarly, when you consider cos of C, so the side adjacent to angle C is BC upon hypotenuse, so which is AC. So, this is coming out again x over AC. So, this let us consider this as 3 and this as 4. So, you can obtain from 3 and 4 that cos of A is same as cos of C. Now, before we proceed for the third and fourth part, we may make use of the Pythagoras theorem. So, here we consider that this AB is x and BC is also x because they are the sides opposite to the equal angle. So, now using Pythagoras theorem, so we consider the Pythagoras theorem. So, here if you look at this triangle, so AC is the hypotenuse, so that will be AC square is equals to AB square plus BC square. So, that will be x square plus x square. So, it is coming out as 2x square. So from here you will obtain AC as square root of 2 multiplied by x. So this is our AC. Now why we calculated this? Because if you look at the part third and fourth, so here we have to obtain the value of sin A plus cos A and tan A plus cot A. So for numerical value we need AC in numerical form. So if you add sine of A plus cos of A, so sine of A is x over AC. So this is x over AC, so that will be root 2x plus cos of A is AB over AC, so that will be x over root 2x. So this gives us 1 over root 2, because you can cancel x, and plus 1 over root 2. So this is coming out as 2 over root 2, and this is coming out as root 2. So this is how we can prove the third part. Now in fourth part we have to obtain tan A plus cot A. So for the fourth part, so this is our third part, so we have to obtain tan A, the value of tan A plus cot A. So tan A, if you look at this diagram, so tan A will be when you consider the angle A, so we have to consider the side opposite to the angle A, BC, upon the side adjacent to angle A, so that is AB. So that will be BC over AB. So this is coming out as BC over AB. Now similarly, when you consider the cot of angle A, so that will be side adjacent to angle A, so that is AB divided by the side opposite to angle A, so which is BC. Now so this is x over x, so this is coming out as 1, and similarly this will be again x over x, so this is coming out 1. So from here, if you add tan A and cot of A, so that will be 1 plus 1, and this is coming out as 2. So this is how we can prove the fourth part. Okay, so this is just simple applications of our trigonometrical ratios for acute angles. Now if you consider the next problem, so in the next problem, so if you consider the problem, so we are given that this triangle ABC is right angled at C, and BC is equals to 12 units, and AC is equals to 4 root 2 units, and angle ABC is theta. So we have to obtain, or we have to determine the values of cos square theta plus sin square theta. Okay, and we have to obtain the value of cos to the power 4 theta plus sin to the power 4 theta, and lastly we obtain the value of cos to the power 4 theta minus sin to the power 4 theta. So, before we begin with this problem, so first of all we have to make the diagram. So, if you consider this right angle triangle, so it is given that it is right angled at C. So, we have to mention this point as C because it is given that this triangle is right angled at C, and let us call this point as A and this is as B. So, we are given the measure of the side BC, which is 12 units, and the side AC is given as 4 root 2 units. Now, we have to obtain these values. So, we know that when we have to calculate the cos of angle theta and sine of angle theta, we have to use this hypotenuse. So, first of all we have to obtain the value of or the measure of this side AB. So, let us begin with the solution, and so here first of all we use our Pythagoras theorem. So, again using Pythagoras theorem, we obtain that AB square is equals to AC square plus BC square. So, this is 4 root 2 whole square plus 12 of square of 12. So, this will give us 32 plus 144. When we add this, so we obtain this as 176. So, you can write this 176 as 16 into 11. So, this further implies that AB is equals to 4 root 11 because the square root of 16 is 4. Now, we can easily obtain the values of cos theta and sin theta. So, if you look at the problem, so it is given that angle ABC. So, this is our angle theta. So, if you obtain the value of now we can obtain sin theta. So, our sin theta is so again if you look at this angle theta, so the side opposite to the angle theta is, so this is our opposite side AC. So, that is AC over hypotenuse, so AB. So, this gives us that AC is given as 4 square root of 2 divided by AB, which is 4 root 11. So, we obtained this as 4 root 11. So, from here we obtained this as root 2 over root 11. Now, similarly we obtain cos theta. So, cos theta, when you consider this cos of angle theta, so the side adjacent to the angle theta is BC and we have AB. So, this is 12, the measure of BC is 12, and we have AB, so which is 4 of root 11. So, this is coming out as 3 over root 11. So, this is how we obtain sin and cos theta. Now, coming back to the first part. So, in the first part we have to obtain the value of sin square theta plus cos square theta. So, we have to obtain sin square theta plus cos square theta. So, this gives us sin square theta will be root 2 over root 11 whole square plus cos square theta. So, that will be 3 over root 11 whole square. So, this is coming out as 2 by 11 plus 9 by 11, because the square of 3 is 9 and the square of root 11 is 11. So, when you take the LCM, so this is coming out as 11 over 11. So, this is coming out as 1. So, this is our first part. Now, when you calculate the value of now the second part, so we have to obtain the value of sine 4 theta plus cos 4 theta. So, that will be root 2 over root 11 to the power 4. Okay, so yes, so that will be root 2 over root 11 to the power 4 plus 3 over root 11 to the power 4. So, this is coming out as 4 over 121 plus 81 over 121, because when you obtain the root 2 4, so that will be root 2 multiplied by root 2 4 times. So, this will be 2 and this will be 2. So, this will be coming out as 4. Okay. So, this is how we obtain this 4 over 121. Okay. And similarly, if you obtain root 11 to the power 4, so that will be root 11 multiplied by itself 4 times. So, this is coming out as 11 into 11. So, because this root 11 into root 11 become 11, and similarly root 11 become 11. So, this is coming out as 121. So, now, so we continue from here. So, this will be, when you take the LCM, so you obtain this as 121 and 4 plus 81. So, this is coming out as 85 over 121. So, this is the value of sine to the power 4 theta plus cos to the power 4 theta. Now, in the third part, we have to find sine to the power 4 theta minus cos to the power 4 theta. So, this will be root 2 over root 11 to the power 4 minus 3 over root 11 to the power 4. So, this is coming out as 4 over 121 minus, this is in fact I think we did a mistake here. We have to obtain cos to the power 4 theta minus sine to the power 4 theta. Okay. So, we have to obtain cos to the power 4 theta minus sine to the power 4 theta. Okay. So, we have to consider cos to the power 4 theta minus sine to the power 4 theta. So, that will be coming out as so cos to the power, cos theta is 3 over root 11 to the power 4 minus sine to the power 4 theta. So, that is root 2 over root 11 to the power 4. So, this is 81 over 121 minus, we obtain this as 4 over 121. So, this is coming out as if you take this 121 as LCM. So, this is coming out as 81 minus 4. So, that will be 77 over 121, and you can cancel this by 11. So, you will obtain as 7 over 11. So, this is how we can obtain the value of cos to the power 4 theta minus sine to the power 4 theta, which is coming out as 7 by 11. So, this is how we can obtain different values of sin theta, cos theta, and some relation given in terms of sin, cos, and some other trigonometrical ratios once we are well aware about the sides of a triangle. So, in the next video, we will discuss about the trigonometrical ratios of some specific angles. So, that is all for this video. Thank you.